Newton had a very unique ability. He easily converted any cited event into mathematical equations. Laws of gravitation was also among one of them. In this he said that gravity is nothing but a force which seems to act between two masses. But on this point, Einstein raised a question. What if one has a mass and the other massless? That is a photon. So will the gravitational force work between them? According to Newton, photons do not have mass. So there will be no gravitational force in it, due to which it will also violate the laws of conservation of momentum, which will be against the laws of physics. And apart from this, Newton had also never mentioned what is that thing which applies this gravitational force. In view of all these things, Einstein presented to us the fact of his general relativity, in which he has expounded all these questions and even much more. According to him, gravity is not a force but a result of curved space-time. Einstein told us through his field equation that wherever there is more energy in space, we get to see curvature or distortion in space and vice versa. So let us know more about these curvatures in detail. The infinitesimally small part of a curvature is known as geodesic, and it is defined as the shortest path between 2 points on a curve. Like the shape of our earth is a sphere, but when we look it from the surface it is flat. Similarly, the geodesic is the straight line or a tangent to the curve. By joining all these geodesics, we will get a space-time curvature. Now let us understand this from some mathematical aspects, so that you can understand it more deeply. One of the central characteristics of curved spacetime is that the parallel transport of a vector becomes non-trivial. The parallel transport of a vector refers to sliding a vector along a curve so that it is always tangent to the curve. In a Euclidean spacetime, this is easy. Just follow the direction of the tangent vector at any given point and the vector will always be tangent. But in curved spacetime, however, it is not so easy. In this diagram, a vector has been parallel transported along the surface of a sphere in a closed loop. The vector starts out parallel to the curve and remains fairly parallel as it follows the tangent vector. As it rounds the top of the loop, where the curvature of the loop is large, however, sliding it along the tangent shifts the direction of the vector. After going around the entire loop, the vector has shifted by an angle of alpha with respect to its initial direction. To fix this problem, one must have to modify the parallel transport vector in a curved space. Before solving this, I have to introduce few facts because we will take the help of these facts to solve this. Suppose both the vector and tangent shows the acceleration of a particle. So along the tangent, there must be a tangential acceleration of a particle under gravity, as per Newtonian physics. But if Newton's concept regarding gravitation are wrong, then the equation of tangential acceleration is also wrong. So we have to improve this equation so that we can apply this on curved spacetime structure. To solve this, we make an assumption that the acceleration under spacetime curve must be 0. And how I considered it, I will tell you about it later. We apply multidimensional chain rule on this equation and we get this equation which is known as geodesic equation. The left part of this equation follows the Newton's laws and the right part is the correction which connect the Newton's equation to the Einstein's curved spacetime model. So when we talk about geodesic, we consider a very small part. So it is obvious that when a particle moves on a geodesic, the speed of the particle for a very small interval must be constant. Hence the acceleration is 0. Geodesic equation has lots of significant effect in modern world. It helps to determine the path of any object in a space-time. It is also helpful in determining the shape of this universe and in many more other fields, like in gravitational lensing. And another interesting fact about this equation is that it can also be used to find the motion of gravitational singularity. But this claim remains disputed. So guys, that's all for this video. Please don't go without liking this video. It took lots of my efforts to make this video and at least I deserve one like from your side for this hard work. Also share this with your friends and subscribe my channel so that I could reach my second milestone of 500 subs as soon as possible. So at last, thank you for watching.